to give a brief introduction on the topic string theory. My name is Arya, and let's begin. So, string theory is mostly like a successful theory which combines two or three smaller other theories which were in the past centuries, which include quantum gravity. So, two of these include Newton's gravitational theory and Einstein's general theory of relativity. So we use string theory in levels of magnification. So if we want to magnify atoms up to a very minute level, we could use the string theory. Right now, these we use different kind of laws in this theory, and this theory works doesn't work completely. It's still a theory in process, and physicists are continue to work on this theory. So I'm going to introduce some key elements of this theory. So there are five key ideas. The string theory predicts that all objects in our universe are composed of vibrating filaments, or so every object or an atom is a wave. String theory attempts to reconcile general relativity with quantum physics. So, Einstein's general theory of relativity and quantum physics are related in this theory. String theory provides a way of unifying all the fundamental forces in the universe, like all gravitational force, nuclear force, and other forces are related with each other. String theory predicts a new connection called supersymmetry between two fundamental different types of particles, bosons and fermions. String theory predicts several extra dimensions of the universe. They can include up to 26 or more dimensions. So there are some fundamental other terms which we need to learn in this presentation. Strings, extra dimensions, dualities, and branes. Strings, a starting point is the idea that point-like particles in quantum field theory are modeled as one-dimensional object called strings. So an atom can move in a path, and that path retraced is called a string in this theory. There can be more than one dimensions up to in the bosonic string theory, space-time is up to 26 dimensions. Compactification is a process in which the number of dimensions are reduced into a different form of circles so that they can be represented in a 3D plane. Duality. The term duality refers to a situation which is seemingly difficult, where seemingly different physical systems turn out to be equivalent in a non-trivial way. So, from the quantum field theory, we get two dualities, S duality and T duality, and both the charts are related to each other in certain ways, and the relation is called a duality. A brain is a physical object that generalizes the notion of a point particle in higher dimensions. So if you want to show a point in a four-dimensional space, you use a brain, or if you want to show a point as a string, its point is a zero dimension. If you want to show a string which is second two dimension, you can use a brain. So I would like to talk about the geometrical formulation of this theory. So ADS and CPT is the correspondence. So an approach to formulating the string theory is provided by anti-D Steiter conformal field theory. This is a very important mathematical formulation through which string theory can be compactified. This is a theoretical result which implies that string theory has some cases equivalent to quantum field theory. So quantum field theory is the main basis of all uh, all this theory. In this theory, the geometry of space-time is described as a certain vacuum solution of Einstein's equation called the anti-De Sitter space, similar to Gaussian space. Uh, this is a space through which there's a conformal boundary. It is closely related with hyperbolic space and can be viewed as multiple layers of disks. This construct will describe a hypothetical universe in which two space dimensions and one time dimension. So up and down are the two space dimensions, and the vertical is the y-axis time dimension that can be generalized into any number of dimensions. Indeed, a hyperbolic space can have more than two dimensions, and they stack up as hyperbolic spaces to get a higher dimensional model. The boundary of the anti-test space is called space-time in quantum field theory. This claim is that the quantum field theory is similar to the gravitational theory, such as this. So I would like to explain the other two schools of thought in gravity so that we could relate it to we can relate both of them with each other to understand string theory. So physicists were searching for a theory of quantum gravity because the current laws of governing gravity didn't work in all situations. They were getting more and more obsolete day by day, with more and more parts of the atom being found. Gravity is an attractive force that binds together, seemingly across any distance. Formulation of the classical theory of gravity by Sir Isaac Newton was one of the greatest achievements of physics. So, but 2 centuries later, the invention of gravity by Albert Einstein changed the equations entirely. Despite the success of Newton's theory, he had a few nagging problems in the back of his mind. First, the fact that he had a model of gravity, but he didn't know why the force actually worked. The gravity that he had described was almost mystical force that was across 2 distances. He just gave a mathematical formulation, but didn't describe why it happened. Instead of gravity as a force acting between two objects, Einstein 2 centuries later, envisioning instead envisioned it that the universe in which each object's mass caused a slight bending of spacetime around it. The moment of an object along the shortest distance in the spacetime was gravity. So the moment of any object which bends the spacetime graph, he called it as gravity. Instead of being a force, gravity was an effect of geometry of spacetime itself. Instead of uh, having actual implications of the object, it was an effect of the object rather than the object causing something else. It would take string theory to bind both of these fundamental views together. So we have two formulas here, and to combine the two formulas, we use the ADS and CPT correspondence. So I would like to talk about the applications of the string theory in day-to-day life. Black holes. In general relativity, black holes are defined as a region of space of time that in which gravitational field is so strong that no particle or radiation can escape. So it has its consolidated mass, uh, and it is deemed to be born out of stars which have died millions of miles away. The string theory proved an important tool for investigating theoretical properties of black holes because it provides a framework in which theorists can study their thermodynamical equations. So Jacob Bekenstein suggested that the entropy of a black hole is the amount of randomness of a black hole is instead proportional to the surface area of its event horizon. Event horizon is the outermost edge of a black hole. So the formula is as follows: the Bink the Bekenstein-Hawking entropy formula gives the expected value of the entropy of a black hole. Finding such derivation of the formula was considered an important test for the theory of quantum gravity by the string theory. Quantum gravity. The discovery of ADS and CFT corresponding was a major advance in physicists' understanding of string theory and quantum gravity. One reason is that it provides a general framework in which physicists can understand and attempt to resolve paradoxal black holes. So, in such a vast set of formulas, it gives point by point and step by step derivations of mathematical equations. The ADS and CFT correspond to resolves black hole information paradox, at least to some extent, because it shows that black hole can evolve in a manner consistent with quantum mechanics. So the randomness of a black hole can be mathematically calculated through this theory. These particles obey usual rules of quantum mechanics in a unitary fashion, so that the black hole must also evolve in a unitary fashion. In 2005, Hawking announced that the paradox had been settled in the favor of information conservation by ADS and CFT correspondence. So, because of the string theory's basic underlying principles, they could solve quantum gravity and could come up with the more coherent formulas to understand it. This is one ways of compactifying extra gravity dimensions in string theory. As gravity is another dimension, we can visualize gravity in the form of an actual dimension. Nuclear physics. So one physical system that has been guided using the ADS-CFT correspondence is quark-gluon plasma. Quark has one-third of the charge of an electron as an exotic state of matter producing particle accelerators. One of the biggest particle accelerators is CERN, through which we discovered the Higgs boson particle. This state of matter arises for a brief instance with heavy ions such as gold or lead nuclei collided with high energies, which we saw in the Rutherford model. Such collisions cause quarks that are made up of atomic level nuclei to decombine at temperatures at approximately 2 or 3 trillion Kelvin, which is then similar to in 10 or 11 seconds after the Big Bang. So we use a particle accelerator and try to make assumptions on how the Big Bang could have occurred at that period of time. In an article, Son and his collaborators show that the ADS-CFT correspondence could be used to understand some specific quark-gluon plasma by describing the language of string theory. By application, he and his collaborators have described that quark-gluon plasma could enhance its perception in dimension space-time. So he could calculate the volume, density of entropy, and most of the other constants used in nuclear physics. So here you can see a magnet levitating above a high temperature superconductor. So superconductors conduct ions in a way in which other alloys or other types of metals don't. These are extremely conductive materials. Most of them are laced with either liquid nitrogen or very high temperatures. So there are many critics of this theory too. Many critics of the string theory have expressed concerns about the large number of possible universes because it's a string and string can be evolving anywhere in a 26-dimensional universe. There can be that many more universes formed out of each and every plane. Some physicists believe that a large number of solutions is a virtue because it may allow natural anthropic explanation of observed values of physical constants and a particular small value of cosmological constants. So cosmological constants are very big numbers for bigger equations, and physical constants are used for smaller and smaller equations. So that's all for this presentation. I hope you liked it and hope you enjoyed it. See you guys in the next presentation.